Hey, good morning, Stemmies. Happy Monday. We are here to talk to you a little bit more about thermal energy today. So, on Thursday last week, we had you go through and read 15.1 in CK12, which was all about thermal energy. And today we're going to kind of go back to that and take a little bit of a deeper dive into this idea of thermal energy. So, if you were with us last year and it references this in the directions, you may remember something kind of similar to this model setup. But if not, you should be able to get caught up pretty quickly. So just to read you in the beginning what it says is, in the past, we've talked about using models to help show our thinking. Students who were with us last year, like I was just saying, may remember using models to show how the scent of an object can move from the object itself to the olfactory sensors in someone's nose that allows them to quote unquote smell the object. Today, you will need to create a similar model, but this time show the amount of thermal energy in different objects. So we actually talked about thermal energy a little bit in that conversation last year, if you remember. But really what we want to dig into today are these three different things. So we have hot soup that was roughly 100 degrees Celsius. We have a spa, hot tub, jacuzzi, whatever you want to call it, that was 38 degrees Celsius. And then we have ice cubes, which are 0 degrees Celsius. So if you haven't noticed before, the cool thing about the Celsius scale is that it is 0 degrees at water freezing, 100 degrees at water boiling. So 38 somewhere in the middle there. It's nice and warm for a jacuzzi, but it's not boiling. You're not going to cook in like a giant witch's vat in a hot tub, which would be bad. That would be a bummer. Anyways, each model that you draw should have the following things labeled in it. So particles, thermal energy, and movement. So how you draw that, how you represent that is totally up to you. The one thing that I would encourage you to maybe think about is kind of that same representation we used last year. So if you remember, we did something like this where we had the particle right here was moving, and if it was moving faster or more, there was more energy there. This line would be longer. If it wasn't moving very far or very fast, there wasn't a lot of energy. It would just be like a short little arrow here. So that's what I would encourage you to use as part of your model, or kind of like the framework for your model. But you're still going to need to go through and talk about how each of these things, the soup, the spa, and the ice, all have different amounts of thermal energy and how you can represent that with the particles. So remember, the soup is made up of a ton, millions of little tiny particles. It's not like you have one particle just kind of floating around. Same thing with the other two options as well. So when you're doing this, we want to make sure that you don't just have one or two little dots and then that's all you have. There should be a whole bunch of things kind of moving around there. I would encourage you to use Notability. If you're savvy with Notability, there are a lot of little kind of workarounds you can do to make that a little bit faster. If you don't know, you can either reach out to Mr. Hoffman or myself, or obviously you go to school with a large number of people who are absolute amazing Notability users that probably know far more than I do. So today, what you need to do is create those thermal energy models for the three different items and kind of show how they're different. And then lastly is just this one question. It says, as described above, the soup has a higher temperature than the spa, but the spa has more thermal energy. Use the ideas from your table above to help explain how this is possible. So when you're doing that, you're probably going to need to reference some of the tables that you have here. If you want to put images back in there and talk about how that may be, I would encourage you to do that. That might be helpful. As we always talk about, a picture is worth 1,000 words, especially if it's a nice labeled, well-drawn model that you can use to help explain that. One of the big things that I will remind you is, if you do go through and you're kind of thinking about this and figuring out how exactly you could do it and you're stumped and you're not sure, probably the best thing you could do, the best first step you could take before reaching out to ask. And obviously we love to answer questions, but one of the biggest things I'm going to say right away when you reach out is, have you gone back and read through the reading again? Because if you go back and look at the reading that we have linked here, it's just exactly what you read on Thursday. There's a lot of information in here that talks about some of the things that you're looking at in this activity. So as you go through, you can see, I mean, here's where the soup and the spa came from. I just added the ice cubes, But if you look at some of this stuff, there's a lot of information in there that might be very helpful for you as you look to create those models and answer that question. So we're thinking today should be pretty straightforward, creating those models, answering the question, and that's all we have for you. So with that, we hope you have a great rest of your day. As always, we're available from 9 to 11 in WebEx for questions. Otherwise, reach out an email or however else you can get a hold of us. We hope you're having a great day. Stay happy, stay healthy, and we will talk to you tomorrow.